Water is important for you. I'm sure many of us have heard this in our lives. But what makes water such an important factor to us? Water holds heat energy well and evaporates at a high temperature. It also has a high density of 4 degrees Celsius and is able to stick to itself for other substances. To understand its importance, we first need to understand its chemical makeup. The chemical formula of water is H2O. Water is a highly polar covalent molecule, meaning the water molecule includes 3 atoms sharing electrons, but the electrons are shared unequally. Its high polarity gives water many properties making it essential to life. Since water is a polar molecule, the charge on the oxygen side is slightly negative, whereas the charge on the hydrogen side is slightly positive. This allows a hydrogen bond, a weak attraction between a hydrogen atom on one molecule and an oxygen atom on another. A single hydrogen bond can be easily broken, but multiple hydrogen bonds are collectively stronger. Because there's so many hydrogen bonds, water has a high heat capacity, allowing water to absorb heat without greatly changing its temperature. 1 calorie is the amount of energy it takes to raise the temperature of 1 gram of a substance by 1 degree Celsius at 1 atmospheric pressure. The ability to hold on to heat and not raise or lower temperature significantly is very helpful in maintaining internal temperatures in organisms, even when there is a rapid temperature change in the environment. The property of having a high heat capacity allows cells not to freeze solid in the winter, nor burst into steam in the summer. When water boils, it evaporates into the atmosphere. It takes 540 calories of energy to change 1 gram of water from liquid to a gas. This is caused by the many hydrogen bonds to be broken before water can boil. This high heat of vaporization allows animal and hot environments to lose excess body heat. When an animal sweats, so much energy is pulled from the body in the form of heat to make sweat evaporate that the animal ultimately cools down afterwards. Water molecules are cohesive and adhesive. Cohesion is the attraction between the same substance, such as water molecules cling to each other. Cohesion works in such a way to minimize the surface area, known as surface tension. When we put water molecules on a penny, we see a dome-like shape form on the surface, made with the help of cohesive forces. Adhesion, alternatively, is the attraction between 2 different substances, such as water molecules and glass. This is why we see concave meniscus in glass tubes containing water. Together, cohesion and adhesion can create a motion called capillary action, as seen inside a plant stem. As water is absorbed through the roots, the water molecules cling to themselves and create high surface tension. Along with this cohesion, the water molecules attach to the walls of the xylem and begin to rise. Once transpiration occurs, the water in the stomata leaf evaporates and ultimately pulls more water molecules up along the plant. Ice is less dense than liquid water, enabling ice to float on the surface. The water under that ice layer will remain around 4 degrees Celsius, which allows organisms to live. Water is most dense at 4 degrees Celsius because hydrogen bonds become more rigid and open, but the molecules are still moving, allowing water to circulate. If the ice were to sink to the bottom surface of a pond, the body of water would freeze over and life would be impossible. As you can see, water isn't just another regular liquid. It is an important component that allows it to exist. So next time you look at another glass of water, think, what are you looking at?